Hello, everyone, and welcome to Best Practices for Amazon S3. I am Vijeta Chakraborty, a Senior Product Manager for Amazon S3. Joined with me today is Naveen Nalam, Software Engineer in the Infrastructure team at Airbnb. On today's agenda, we'll start by covering storage classes, data protection, and ways to optimize your cost. We have a customer spotlight on Airbnb, and finally, we will touch upon a few security best practices. Let's start with an overview of Amazon S3. Most customers in the cloud use Amazon S3 as their storage and data lake solution because it has the most functionality and unmatched availability, durability, and scalability. The one feature I'd like to highlight today is scalability. Scalability is one of the key benefits of S3 storage, as it frees you up to focus on more important aspects of your business. It's easy to get started and grow to petabytes of storage without worrying about capacity planning or hardware. The storage scales as you do. Let's dive right into Amazon's S3's different storage class offerings and talk about how you can use them to cost optimize as well as meet your performance needs. Since its introduction in 2006, Amazon S3 has constantly innovated on behalf of our customers to make cloud storage more cost-effective and easier to manage. The graph you see on the left shows over 80% reduction in S3 standards price since 2006. On the right, you're seeing how we've continued to add more storage classes over time. I wanted to draw your attention to two new launches. One, we've launched new archive and deep archive access tiers to our intelligent tiering storage class because customers wanted the flexibility of automatically moving data to the lowest storage cost offerings. Two, we've launched Amazon S3 Outposts to meet customers' requirements of keeping their data close to on-premises applications. Amazon S3 has a number of storage classes to choose from. So how do you know what's best for you? Let's walk through a few examples. 1. If you know that your data is active and frequently accessed and may be deleted within a month, S3 Standard is the best choice. Designed for 99.99% availability, milliseconds latency, and protection against a single AZ loss. If you know your data is less frequently accessed and not deleted within a month, use S3 Standard Infrequent Access to save up to 40% storage costs compared to S3 Standard, but with a retrieval fee for accessing the data and a minimum storage duration of 30 days. Another use case could be that your data is reproducible and is less frequently accessed. Then you can consider using S3 One Zone Infrequent Access, which stores data in a single AZ at 20% lower storage cost than S3 Standard Infrequent Access. Another option is to archive objects via lifecycle policies from any S3 storage classes into Amazon S3 Glacier or Amazon S3 Glacier Deep Archive. The Glacier storage classes can save you the most money and are designed for minutes to hour retrievals. For those of you who don't want to think about access pattern or have data with unknown or changing access patterns, we recently launched S3 Intelligent Tiering support for two new archive tiers. S3 Intelligent Tiering now supports automatic data archiving, helping customers to further reduce storage costs by up to 95% when objects become rarely accessed over long periods of time. Amazon S3 provides you different tools to manage large shared data sets. We have S3 Inventory, a feature for analyzing individual objects within your buckets. We also have S3 Storage Class Analysis, which analyzes access patterns in buckets to recommend an optimal storage class for you. We recently launched S3 Storage Lens, our newest S3 Analytics and Insights feature, which provides centralized, organization-wide visibility into your S3 storage usage and activity, as well as recommendations on how you can optimize your storage. With all of these analytics and recommendations, you can learn more about your data access patterns and Choose the right storage class that meets your performance and cost requirements. With Amazon S3, we provide you flexibility to manage your objects and storage classes. You have the option to use S3 analytics tools with S3 Lifecycle to transition to a different storage class like Glacier Deep Archive. Or you have the option to give Amazon S3 the ability to analyze your access patterns automatically and move your objects to infrequent, archive, and deep archive access tiers with S3 intelligent tiering. We'll talk about both of these options in the upcoming slides. Let's look at S3 Lifecycle first. Lifecycle policies are rules that you can set up to move objects to another storage class after a given number of days. These rules are based on the creation date of the object and can be filtered to apply to the whole bucket, prefix, or tagged objects. For example, you can move objects older than 30 days to S3 standard, infrequent access, and move objects older than 365 days to S3 Glacier Deep Archive. Next, let's look at S3 intelligent tiering. S3 intelligent tiering is great for customers who want to optimize storage costs automatically when data access patterns change without performance impact or operational overhead. S3 intelligent tiering delivers automatic cost savings by moving data between 4 access tiers: frequent, infrequent, archive, and deep archive access tiers. The frequent tier in S3 intelligent tiering is priced the same as S3 standard. An infrequent access tier is priced the same as S3 standard infrequent access. So you're able to save up to 40% as data moves to the infrequent tiers. The new archive and deep archive tiers are priced the same as Glacier and Glacier Deep Archive. Intelligent tiering does not have a retrieval fee, so even when the data moves to these other tiers, there's no per GB fee for access. There is, though, a monitoring fee for objects in intelligent tiering to monitor access and to do automatic tiering. So it's probably best for those larger objects, 1 megabyte or more. Next on our agenda is data protection with S3. Let's look at S3 versioning and how it works. S3 versioning is a means of keeping multiple variants of an object in the same bucket. You can use S3 versioning to preserve, retrieve, and restore every version of every object stored in your Amazon S3 bucket. With versioning, you can easily recover from both unintended user actions and application failures. This example here illustrates how versioning provides protection against overwrites. As you can see, an overwrite of an object here results in a new version of the object in the bucket. If you delete an object without a version ID, Amazon S3 inserts a delete marker, which becomes the current object version. This way, you can always restore the previous version. A get operation on an object with a delete marker leads to a 404 error. But let's say you want to delete an object with a version ID. In that case, S3 does not add a delete marker and instead actually removes that version of the object from your bucket. Next, let's take a peek at S3 replication. Many of our customers use S3 replication for data protection. S3 replication gives you several options. For example, you can replicate within the same AWS region with S3 same region replication or S3 SRR, or to a different AWS region with S3 cross-region replication or S3 CRR. We recently launched the capability to replicate from a single source bucket to multiple destination buckets in the same or different AWS regions. You also have the option to replicate data across different AWS accounts or between buckets with different object lock retention controls to further secure your data. Finally, if you need predictable replication backed by an SLA, S3 replication time control lets you replicate objects within 15 minutes of upload. I wanted to provide some more details on S3 replication time control, or S3 RTC. S3 RTC is designed to replicate 99.99% of your objects within 15 minutes of upload, with replication typically completing in seconds. You get an SLA commitment that says that 99.9% of objects will get replicated to your destination bucket. S3 RTC can be applied to the entire bucket or a subset of objects filtered by prefix or object tags. With S3's replication ability to replicate data to multiple destination buckets, you now have the flexibility of enabling S3 RTC on any or all of the region pairs. Another data protection measure that our customers like to use is object locks. Object locks are a good way to protect critical objects from getting deleted or overwritten. With S3 Object Lock, you can store objects using a write once, read many, or WORM model, and this helps many of our customers with their regulatory requirements. Object locks gives you two options for protection: retention periods and legal holds. A retention period specifies a fixed period of time during which an object remains locked. During this period, your object is WORM protected and cannot be overwritten or deleted. In contrast, a legal hold provides the same protection as a retention period, but it has no expiration date. Instead, a legal hold remains in place until you explicitly remove it. You can set object locks on an individual object or really easily as a bucket level setting to apply to all new objects. Okay, next, let's talk briefly about a few of the analytics and insights tools on S3. We recently launched S3 Storage Lens, and we have received great feedback from our customers on this particular feature. Let me give you a quick overview of how S3 Storage Lens works. First, it provides a large number of metrics, 29 in total, including both usage and activity, all of which are updated on a daily basis. S3 Storage Lens provides aggregation from the highest level, AWS organizations, down to a very granular level of prefix. You have up to 15 months of historical data to analyze, enabling you to analyze long-term trends and patterns. Finally, you have a highly visual interactive dashboard which is embedded in the S3 console, which can be used to slice and dice, drill down, and perform many other standard dashboard interactions on your metrics. S3 Storage Lens also gives you recommendations on how to optimize storage costs. I wanted to highlight the four major use cases on how customers can use S3 Storage Lens. First, for summary insights, which are the top-level learnings like how much has my storage increased across my entire org in the last 90 days. Second is for outliers, which are call-outs for usual upward or downward spikes based on a statistical evaluation of your data over the last 30 days. Third could be for data protection, such as replication, encryption, or object lock. Here you can use metrics to identify gaps in your data protection policies. And the fourth and final use case is cost efficiency, where you can surface insights that may point to potential storage cost reductions, such as identifying your infrequently accessed buckets. Here's a quick example on what summary insights on S3 Storage Lens could look like. In this example, we focus in on our storage distribution to learn that 43% of our storage is in the standard infrequent access. Another important tool is percentile metrics on CloudWatch that can help you spot outliers and understand the distribution of access patterns. As a best practice, customers use CloudWatch metrics to visualize the request patterns and alarm on outliers. Let me pause here for a brief period so we can hear from my co-presenter Naveen on how Airbnb has made the best use of S3.
Thank you, Bijeta. Hello, everyone. I'm Naveen, and I'm here to talk to you about how Airbnb uses Amazon S3 features to optimize our storage costs and how Amazon S3 is used for data protection. There are several use cases within Airbnb where Amazon S3 is used. For example, we use S3 for storing photos of homes listed on our service and other user-generated content. For data and analytics, S3 is used with Amazon EMR, which allows us to scale storage and compute separately. For our search service, we generate search indexes and store them on S3. During deployment, these S3 objects are loaded into the memory of the search backend services. We use S3 as the storage for various logging systems like AWS CloudTrail, S3 Server Access Logs, and VPC Flow Logs. We also back up our various data stores such as Redis, etcd, and Elasticsearch by taking periodic snapshots and storing them on S3. There are a few best practices of S3 that we use across all of these use cases, and I will dive into those details next. First, let's talk about how Airbnb optimizes storage costs with Amazon S3. Across our S3 buckets, we use different S3 storage classes to optimize on costs. In our production AWS environment, new data is primarily stored into the S3 standard storage class. For specific data, we use lifecycle rules to later transition from the standard storage class to either intelligent tiering or the infrequent storage access class. For example, on our buckets that store objects used by our data warehouse, we save costs by transitioning data from the standard storage class to intelligent tiering after the data has aged 30 days. We saw with intelligent tiering, more than half of that data was moved to the infrequent access tier, and with the relatively small cost in monitoring and transition fees, our storage costs reduced by approximately 27%. Another example is for buckets that store logs or build artifacts. Based on access patterns, we found that older data was rarely accessed. We were able to reduce costs by using a lifecycle rule to transition data after 30 days from the standard storage class to the infrequent access storage class. We also replicate all our production Amazon S3 buckets to buckets in another region for backup purposes. In some of the replicated buckets, where we can tolerate longer data retrieval times, we take advantage of the lower cost Glacier and Glacier Deep Archive storage classes. There are 3 tools from AWS that we use for helping us understand our S3 costs and how we can optimize those costs. The first is the Amazon Cost and Usage Report, which we've enabled on our AWS account to generate data hourly. This lets us understand the cost of an S3 bucket, such as how much we are spending on data transfer or data storage. The second is the S3 Inventory Report, which we've set to be generated weekly on our S3 buckets. This lets us understand the storage use by prefix in a given bucket. This has been especially helpful on some of our large buckets that have many different data sets. The third is S3 Server Access Logs. This lets us understand the usage pattern of data, which we can utilize to determine when certain data can be deleted or transitioned to a lower cost storage class. We ingest the cost and usage report into our data warehouse and generate reports which allow us to look at trends and identify outliers. In this screenshot, we can see an example of an outlier in the top right graph. This was a result of a planned operation where we enabled lifecycle rules on a few buckets to transition existing data from Glacier to the Glacier Deep Archive storage class. We're also very interested in using the new S3 storage lens and seeing how it can fit into our workflows. With the S3 Inventory Report, it is ingested weekly into our data warehouse. We use the S3 Inventory to analyze storage use by prefix within a bucket. For example, the query shown was used during a past data cleanup effort. We wanted to calculate data size by prefix in order to prioritize prefixes to investigate. For S3 server access logs, these are often used in combination with the inventory report. When looking at object prefixes within a bucket, we use the server access log to understand the access pattern over time. For example, we had a use case where we wanted to understand if older objects with the given prefix were still being accessed. The query shown joins the inventory report with the server access logs and shows the age of the oldest objects being accessed. From this, we chose to set a lifecycle rule to expire data in this prefix after 30 days. Now I will talk about how we protect data using Amazon S3. To prepare for the possibility of complex data loss scenarios for different regions in the United States, we back up all our production Amazon S3 buckets to a separate AWS account, where the buckets are stored in a different US region than the source buckets. We use S3 replication feature to do the cross-account and cross-region backup. Our Amazon S3 configurations, which include the replication configuration, are all managed by Terraform, a software tool from HashiCorp. Each S3 bucket's Terraform configuration file is first auto-generated by an internal tool that takes in various parameters, one of which is the destination storage class of the replication. We classify S3 buckets based on the priority needed following a data loss event. For high-priority data, such as photos of homes, we store the replicated data in this S3 standard storage class. For data that has lower priority in recovery, such as certain datasets in our data warehouse, we store the data in our S3 Glacier or S3 Glacier Deep Archive storage class. We're also interested in seeing how we can leverage S3's new ability to replicate to more than one destination bucket. On our production buckets, almost all have versioning enabled. For the majority of our S3 buckets, we use a shorter retention period for the deleted objects on the production S3 buckets, and use a longer retention period on the replicated S3 buckets, where the costs are also lower due to using the Glacier or Glacier Deep Archive. This setup gives us the ability to often recover data directly from the production buckets in strict emergency situations. We use the S3 inventory report to understand the data usage within a bucket by object prefix. The S3 inventory report is also used to audit and report on the replication status of objects in our production S3 buckets. We found S3 replication to be very reliable, but there can be occasional failures. For example, due to an accidental misconfiguration, objects can fail to replicate. The inventory report is ingested into our data warehouse, where it can be further queried using Presto or Hive. Hive is used to generate reports that indicate replication status by bucket. When objects fail to replicate, we use Presto to generate a CSV file that can be provided to an S3 batch operation. The S3 batch operation copies objects in place, generating a new version of the object to redrive replication. In summary, we've covered how Airbnb uses different storage classes and features of Amazon S3 to optimize our overall storage cost. And we've discussed how Airbnb leverages S3's versioning and cross-region replication to protect data. Thank you, and back to Bijeta to discuss more about S3.
Thank you, Naveen. That was great. We have one more topic to present today, security with Amazon S3. With Amazon S3, security is at the core of everything we do. The buckets and objects you store in S3 are secure by default, and we give you granular controls to share that access with others. Let's look at what additionally we provide to secure your data. In the next few slides, we will talk about block public access, encryption by default, access points, and access analyzer. First, let's take a look at block public access. S3 Block Public Access provides settings for access points, buckets, and accounts to help you manage public access to Amazon S3 resources. By default, new buckets, access points, and objects don't allow public access, but users have the option to modify bucket policies or object permissions to allow access. Block Public Access settings lets you override these policies and permissions so that you can limit public access to your data. S3 Block Public Access provides 4 settings as you can see on this slide. These settings are independent and can be used in any combination. Each setting can be applied to an access point, a bucket, or an entire AWS account. As a best practice, we recommend our customers to enable Block Public Access on their buckets at an account level. Amazon S3 provides default encryption as a bucket level setting that ensures all new objects are encrypted when they're stored in the bucket. For server-side encryption, you can choose between Amazon S3 Managed Keys, SSE S3, or Customer Master Keys stored in AWS Key Management Service, AWS KMS. We do recommend that our customers enable default encryption as a bucket level setting as an added layer of protection. Next, let's talk about access points. Access points are unique host names that customers create to enforce distinct permissions and network controls for any request made through the access point. You no longer have to manage a single complex bucket policy with hundreds of different permission rules that need to be written, read, tracked, and audited. Instead, with access points, each user or team can have their very own access point with its own policy. We see a number of use cases with access points. Some customers will break out one large bucket policy into separate access point policies for each application that needs access to a shared dataset. Another way customers can use access points is to restrict all S3 storage access to the bucket to go through a virtual private cloud or VPC. Also wanted to talk about S3 Access Analyzer today. S3 Access Analyzer monitors your bucket permissions and gives you visibility into public and cross-account access. You can review at-risk buckets through Access Analyzer and see how the bucket is shared and what access is granted on that bucket. For example, Access Analyzer might show that a bucket has read or write access through a bucket access control list or a bucket policy. Additionally, Access Analyzer also gives you ways to remedy public access that is not intended. For example, you can block all public access through a single click. The last thing I'd like to highlight today is S3 Object Ownership. It's a new S3 feature that enables bucket owners to automatically assume ownership of objects that are uploaded to their buckets by other AWS accounts. By default, an S3 object is owned by the AWS account that uploaded the object. S3 Object Ownership now gives you a simple bucket level setting that changes this default behavior so that new objects uploaded with the bucket owner full control access control list will instead be owned by you. Whether your S3 bucket receives data from other AWS accounts or stores output from AWS services like AWS CloudTrail, S3 Object Ownership simplifies the work of creating and maintaining this shared dataset on Amazon S3. All right, let's do a quick recap of all the things we talked about today. First, we talked about the different storage class offerings on S3 that you can choose to meet your performance needs as well as optimize on cost. We recommend you try S3 Lifecycle or S3 Intelligent Tiering to move data between different tiers to realize storage cost savings. We talked about data protection best practices like S3 versioning and S3 replication. We then talked about analytics and insight features like S3 Storage Lens and Amazon CloudWatch metrics. Last but not least, we discussed a few best practices for security in S3. We recommended turning on block public access at the account level and default encryption on all buckets. I hope that was a good recap. With that, we end our presentation. We are so thankful for all of you that were able to join, and we really hope that you learned something new today.